Venus, our closest planetary neighbor, often conjures images of beauty and tranquility. Its gentle glow in the evening sky makes it easy to see why it's named after the Roman goddess of love and beauty. But as with many things, appearances can be deceiving. Beneath its serene, cloudy veil lies one of the solar system's most hostile and unforgiving places. Imagine a planet with crushing atmospheric pressure, intense heat that could melt lead, and clouds laced with toxic chemicals. That's Venus. In this video, we're diving deep into Venus, the version they didn't tell you about in school. We'll explore why this planet, while appearing calm and graceful from afar, is a volcanic, high-pressure, acid rain-soaked furnace up close. Venus challenges our assumptions about what a planet could be like, so prepare to learn more about this fascinating world. Setting the scene, Venus's place in our solar system. Let's start by placing Venus in our solar neighborhood. Venus is the second planet from the Sun, orbiting at an average distance of 108 million kilometers. Venus has the most perfectly circular orbit of any planet, staying nearly the same distance from the Sun throughout its journey. And when it comes closest to Earth, it's only 41 million kilometers away, making it the nearest planet to us, closer even than Mars. You might think Venus would be brightest in the sky during this close approach, but it's brightest when it appears as a crescent. When it's closer, sunlight refracts through its thick atmosphere, giving it a unique, striking glow. Because of its intense brightness, Venus is often mistaken for a UFO, even by high-profile figures like President Jimmy Carter, who once thought he saw something unexplainable in the sky, which was later identified as Venus. A planetary clockwork mystery, Venus's orbit and rotation. Venus is like the cosmic oddball in our planetary family. All planets in our solar system orbit the Sun in a counterclockwise direction. Venus does the same, but unlike any other planet, it rotates on its axis in the opposite direction, a phenomenon known as retrograde rotation. Not only that, but it has an extremely slow rotation. A single day on Venus, from one sunrise to the next, is equivalent to about 117 Earth days. That means you'd experience just 2 long days over the course of a Venus year. Scientists have long debated why Venus rotates backward, and so slowly. One theory is that a massive collision with another celestial object billions of years ago knocked Venus off its original axis. Another possibility is that gravitational forces from the Sun could have influenced Venus's rotation over time, or it might be due to the effects of Venus's thick, dense atmosphere on its movement. The hellish atmosphere of Venus. If Venus is Earth's twin in size, that's about where the similarities end. Venus is wrapped in a dense atmosphere that would crush any spacecraft landing on its surface, with a pressure 92 times greater than Earth's. This means standing on Venus would be like standing a kilometer under the ocean. The atmosphere, mostly made of carbon dioxide with clouds of sulfur dioxide, creates an extreme greenhouse effect, trapping heat so efficiently that temperatures on Venus can reach a staggering 462 degrees Celsius, 863 degrees Fahrenheit. That's hotter than Mercury, even though Venus is farther from the Sun and receives only 25% of the solar radiation that Mercury does. This thick blanket of gas means there's almost no temperature variation across the planet. Whether you're at the poles near the equator or on the night side, Venus stays scorching hot. This temperature stability is further reinforced by Venus's slight axial tilt of only 3 degrees, making seasonal temperature changes almost non-existent. Unlike Earth's changing seasons, Venus is a world in perpetual, unchanging heat, fierce winds, and toxic clouds. One of the most striking features of Venus's atmosphere is its wind. Near the planet's surface, wind speeds are relatively slow, just a few kilometers per hour. However, high in the atmosphere, the wind picks up dramatically, reaching speeds up to 300 kilometers per hour, about 186 miles per hour. These high-altitude winds race around the planet, completing a full rotation every 4 to 5 Earth days. Because of these high-velocity winds, Venus appears to rotate much faster from space than it actually does. The clouds are made of sulfuric acid, a corrosive substance that can eat through metal. Acid rain falls from these clouds but evaporates before it hits the ground due to the extreme heat. Adding to the strangeness, Venus's clouds are capable of producing lightning, a feature that was only recently discovered. It's rare compared to Earth's thunderstorms, but is another indicator of Venus's volatile nature. Venusian volcanism and surface conditions. Let's descend to the surface of Venus, where we encounter an incredible landscape. Venus's surface is a vast volcanic plain dotted with mountains and lava flows. There are at least 167 volcanoes on Venus that measure over 100 kilometers across. While Earth's crust is broken up into tectonic plates that move and shift, Venus lacks this plate tectonic system. Instead, its surface is considered much older, estimated to be between 300 to 600 million years. This is because Venus has likely experienced periodic global resurfacing events caused by intense volcanic activity without tectonic plates to recycle the crust. During these events, molten rock would have poured out across the planet, covering most of its surface in lava. Thanks to radar mapping missions like NASA's Magellan, we have detailed images of Venus's surface. Radar lets us see through the planet's thick clouds, revealing mountains, valleys, and volcanic plains. In addition to the massive volcanoes, scientists have identified thousands of smaller volcanic structures scattered across the Venusian landscape, indicating that volcanism has been a defining force in shaping the planet. Exploring Venus, pioneering missions and their challenges. Despite its extreme conditions, humans have sent probes to Venus, thanks mainly to the Soviet Union's Venera program in the 1960s and 70s. Venera 7 became the first probe to land on another planet and send data back to Earth in 1970. Though it only transmitted temperature data before succumbing to the extreme heat and pressure, this mission marked a historic milestone in planetary exploration. Later missions like Venera 9, 10, 13, and 14 gave us our first images of Venus's surface. They captured haunting landscapes bathed in an eerie orange glow, showing an alien and strangely familiar world. These images reveal a rocky, barren surface with sharp stones scattered across the ground and a seemingly endless horizon. In recent years, renewed interest in Venus has spurred new missions, like NASA's Da Vinci Plus and Veritas missions. These missions aim to further explore the planet's atmosphere, geology, and volcanic activity. Each mission is another step toward understanding why Venus, which once may have had oceans and Earth-like conditions, turned into the blazing inferno we see today. The missing magnetic field and solar interactions. One of the biggest mysteries about Venus is why it lacks a magnetic field despite having a composition similar to Earth's. Our planet's magnetic field is generated by the motion of molten iron in its outer core, but Venus doesn't have a similar protective shield. This absence leaves Venus vulnerable to solar wind, which strips away its atmosphere and forms a comet-like tail behind the planet. Some scientists speculate that Venus's lack of a magnetic field could be related to a missing massive impact event that might have jump-started Earth's magnetosphere. Interestingly, this comet-like tail occasionally extends far enough to reach Earth, creating a cosmic connection between the two planets. While we can't see it with the naked eye, this interaction highlights how interconnected our solar system can be. A glimmer of hope. Potential habitats in Venus's atmosphere. While Venus's surface is incredibly hostile, there's a surprising possibility for habitability in its upper atmosphere. Temperatures and pressures about 50 kilometers above the surface become much more Earth-like. If you were in an airtight floating structure at this altitude, you would experience gravity, temperature, and pressure similar to what we feel here on Earth. Some scientists have even suggested that Venus's upper atmosphere could be a potential target for future floating research stations, where instruments could study the planet's surface from a safer distance. This potential habitable zone within Venus's atmosphere adds a new layer of fascination to this enigmatic planet. Could Venus be a target for human exploration in the future? It's an intriguing question that we may explore as technology advances. Venus is a world of contradictions. It's stunning and terrifying, serene and violent. Though it may look peaceful from afar, it's a testament to the power of planetary forces hidden beneath a deceptively beautiful surface. Exploring Venus teaches us about our own solar system and the potential diversity of planetary environments that may exist beyond it. If you're as fascinated by these cosmic mysteries as we are, then you won't want to miss our next video. In it, we'll delve even deeper into the universe's secrets and explore recent discoveries that could revolutionize how you understand the cosmos. Remember, knowledge is our most powerful tool in the vast expanse of the cosmos. So, are you ready to learn the secrets revolutionizing how we understand the universe? Click that video now, and let's continue our cosmic journey together. Thank you for joining us on this cosmic adventure. Stay curious and keep looking up.